Invicti Security presents AppSec Serialized, a podcast about web security and those who practice it. Episode 1, Hot Cross-Site Fun. Mallory didn't really need the Z-Bucks. Not really. She had found a new game, emergent from the ashes of the old, more exciting than any she had played before. She had barely touched her tonkatsu ramen. She blinked, looking up from her laptop, and noticed that the noodle bar was almost empty. She'd have to leave soon, but she was so close. She had an idea, one more thing to try. In her experience, it was always the side door that didn't have the lock. The server was old, at least a decade back, judging from the host name. Some sort of public-facing leaderboard for a game long since abandoned. Dusty, unloved, and absolutely perfect. She adjusted the angle of her laptop. There was clearly a web application firewall, a WAF, between her and her target. It was signature-based, had a library of tricks that it would watch out for and individually block. But if she put the right moves into the URL, janked left when it went right, she could work around it. Maybe. For the 10th time tonight, she told herself that she should really automate this. She had found that she could reflect the text that she typed into the site search bar into the source code of the page, but the WAF was already one step ahead, anticipating her, blocking her. Steam no longer rose from the ramen. On a whim, she added in an unusual bit of JavaScript, a mouse hover handler that would pop up an alert box. The payload sailed across the net inside her HTTP GET request, and she inhaled sharply, her heart rate spiking. There, before her, in a gray pop-up, was an alert box containing her attack payload. The on-mouse hover had invoked an alert payload with a string that had no business being in the application she was targeting. Her heart began to pound. The site with the vulnerability wasn't important, but its domain name was. As a subdomain, it was trusted with access to all of the single sign-on persistent state information, the cookies, that targeted the main page. Shinobi was streaming the game, as usual. He had more than 15 million subscribers. She hopped onto his seizure stream and started spamming a URL, a special link that redirected after login to the site with the XSS, the cross-site scripting payload. The chat wouldn't take the full URL, so she had to finesse, get the audience to change a few characters here and there. It was almost too easy to talk the gullible audience into an infinite Z-Bucks hack. The link contained a script tag, with a source going back to an EC2 instance that Mallory had set up with a hostile bit of JavaScript. A kind of Trojan horse that once invited past the walls of the web page's secure boundary could unpack and execute any JavaScript code she wanted. And what she wanted was the OAuth 2 credentials, the keys to the social media accounts of everyone watching the stream who was gullible enough to click. She tailed the logs of her server, looking for the GET requests, including the base64 encoded JSON web token, abbreviated JWT and pronounced JOT. It worked. It actually worked. The tokens poured in faster than her terminal could keep up with, multiple lines of green text spilling over her darkened terminal so fast the characters turned into a blur. She had done it. She had won. In the real world, the neon lights in the ramen bar turned off, leaving her face illuminated by only the pale glow of the laptop, her victory still dancing in the LED's back glow. Someone was yelling at her, something about closing 10 minutes. She hadn't been listening, too wrapped up in her own world, but she had done it. She had solved the game within the game. Her nerves were pure electricity as she smiled a huge grin. She had won. Chicken dinner. Welcome to our first episode of AppSec Serialized, the podcast where we talk about web application and API security. My name is Dan Murphy, and I'm the chief architect here at Invicti Security.
My name is Frank Catucci, and I'm the CTO and head of research here at Invicti Security.
And as you heard in that intro story, cross-site scripting is very, very real. And today we're going to talk a little bit about it in a little bit more depth. So Frank, my first question is, what's in a name? Why is cross-site scripting called cross-site?
Yeah, it's an interesting question that I think has a lot to do with the history of cross-site scripting. This is a vulnerability that goes back a number of years. And if you look at the way applications and websites and things were written previously, they were done in a fashion where everything essentially happened on a site, if you will, or one site. Where cross-site comes in is where you were, loading something either in an iframe or loading something from a different site or running a script via a different site, really crossing the borders or the boundaries, if you will, of one site to another in order to exploit this vulnerability. At least that's my take on the history of the name. That's how I at least describe it and understand how it's evolved to what it is today.
Yeah, totally. I think the first ones back in the day, like with the MySpace worm that started a lot of this stuff. Originally, these were tiny little invisible iframes, and they had a script that came from another place, from another site, from cross origins, and that's that hostile script was able to run on the page and do a lot of bad.
So, Dan, I have a question for you. A lot of people always say, oh, it's cross-site scripting. I'm not sure it's still relevant to be labeled as something like a severe vulnerability on my web application. Let's break this down a little bit and say, what's the worst thing that can possibly happen with cross-site scripting? I think there's a few different ways we could go with that, but what's the worst that could really happen?
Yeah, so one way to think about it is cross-site scripting is about evaluating untrusted JavaScript code in your front end of your app. So think of it in terms of your threat model. It's anything that someone could do through your UI you could achieve if hostile code was executing inside of that front end. And it used to be that, back in the day, it was pretty easy to say, oh, that's just the UI. It doesn't matter that much. But with systems increasingly kind of becoming online, with everything being controlled through a web UI, anything that you can do there can be done. Technically, what you're doing is you're executing code that has access to the full document object model. It can rewrite things. It can exfiltrate data. So you could put in kind of a silent image tag that happens to send your cookies that are associated with the site, should they be accessible to JavaScript, to a hostile third party. That third party could then log in to your site, to a banking account, to transfer funds. So there's a lot of power. You can intercept APIs. You can do pretty much anything that someone could do in the front end. Code can click those buttons. Code can drive things. It can steal data and do a lot of damage. In fact, Frank, that's a good question. What's your favorite example when you talk to people about cross-site scripting? What's your favorite example of something that did happen where damage has been done?
Yeah, this is, we have plenty of examples that we can choose from. I'm going to give you one of my personal favorites just due to impact. And then I'd love to hear yours as well. But
yeah, sure.
This is relatively recent. It was around 2018. British Airways was attacked by MageCart. What they did was they actually exploited a cross-site scripting vulnerability in JavaScript in one of the libraries. I think it was Feedify, that was used on the British Airways site. Now, with the ability to exploit that cross-site scripting, they were able to send basically the customer data to a malicious server that used a similar domain name to British Airways. Now, what occurred here is they were essentially able to skim or get the ticketing and credit card and personal information from over almost 400,000 booking transactions. Now, we're not talking about one or two. I mean, we're talking 400,000 live customer bookings with credit cards, corporate cards, with mile transactions, anything that you could imagine that was being processed in the purchase of those tickets before this breach was even discovered. So, we're talking almost 500,000 transactions. Now, this is a perfect example of how a cross-site scripting vulnerability could be exploited and be detrimental to your company. Let's talk about 400,000 credit cards on a British Airways site. We're talking about PCI violations. We're talking about breach notifications, identity monitoring, etc. If this was a smaller entity, this could have ended the company, right? Super
that's real.
impactful
That's very real.
and expensive for the company. That was just one example, probably one of my favorites just because of the breadth and the depth of the attack and the impact. But Dan, give me an example of what's one of your favorite cross-site scripting examples?
So one that I always love to talk about, and I've used this, when interviewing engineers and things like that over the years, is a story by a gentleman named Sam Curry that cross-site scripting ultimately, it's about not having validation. It's about putting something into a web page that has no business being there. So this gentleman, he got a Tesla. And when you've got a Tesla, the app allows you to name your card. Now, most people are going to name it something innocuous. Hey, this is Bob the car or something like that. And in this case, what this guy did is he named it something similar to less than script, close bracket, or less than script source equals myevilserver.org/foo.js, right? Basically, I'm trying to pull in some code from somewhere on the internet. And he named it, nothing happened. It was protected, so he thought nothing of it. And then kind of months later, he was driving on the highway and got a crack in his windshield. And he used the app to request a change of that windshield. And what happened is that app sent the name of the car, which again was this HTML tag that was trying to pull in content from some other location. And it found its way through a labyrinth of different paths to a backend system at Tesla that was processing these claims. And suddenly he found that his dumb name for his car was being pulled into an internal web page, firewalled off on some Tesla internal app. And what it was doing now is allowing him to inject code from this web server that he controlled into the internal app. And he was able to do anything with access to the DOM. He was able to take a look at what it was doing. Turns out this app was doing geolocation data to show where someone that's doing a service request would need to drive to replace the windshield on a cracked Tesla. Now, showed a picture of his car, showed kind of where it was located, and he also noticed that the location, because the cross-site scripting is executing in the context of that web page, it's easy to take a look at the document.location property and say, hey, this is, cracked windshield request /123. Well, he was able to change that to 124, and he found somebody else's vehicle. He was able to change it to 125, and you can kind of extrapolate from there this simple trick of naming something inside of an app, something that had a little bit of active code, ended up being able to track the location of, every single Model S that was out there to be able to say, where is it on the map? So it's humorous because the vector, it's an input that goes into a web app that ends up executing not on a publicly accessible system, something in the back that should be secure, right? There's tons of internal web apps that don't have the same internal security standards that externally facing stuff does. But this got active, and he was able to get some pretty juicy stuff out of it. It's a great story. Are there different types of cross-site scripting? Like, what flavors can I get that particular vulnerability in?
Yeah, that's an excellent question. So, some people will say there are a couple of different flavors of cross-site scripting. Some will say there are upwards of 3 or 4 types of cross-site scripting. I break these down into 2 major categories. Mm-hmm. One could argue that DOM-based XSS is just a type of reflected and not a stored type of XSS, since it occurs strictly in the DOM. So I'm going to focus on the 2 main categories. One would be reflected and the other would be stored. Mm-hmm. You'll often hear these referred to as either reflective, some will say non-persistent, right, or some will just say reflected and stored, or reflected and persistent. But there's a ton of different ways there. But so I break it down into 2 categories. Now, a reflected cross-site script essentially is is when the user input is returned by an app, either in an error message or a search result, or there's some type of code or script that's being run as part of a search, as part of perhaps the data that is rendered specifically in the browser, as a, on the DOM side, or it's done in a manner that reflects within that session. And that could have, multitude of different types of impact on the reflected piece, right? Having a script that you're allowed to run from a source that gets replayed or displayed on that application. And you mentioned earlier, that code can do things. That code can click buttons. That code can create users. Let's say you're logged in as an admin, and you're vulnerable to cross-site scripting, and all of a sudden you don't realize that you've just created a new admin, but it's a nefarious user. And so there are a ton of things that can occur there. And that's basically what I look at beyond, the simple alert with JavaScript as a test. But that's reflected cross-site scripting. The other one now is usually more serious. And this is kind of like, I look at it sometimes and I'm like, oh, they called this stored XSS, but is this really a type of injection? Kind of, right? So stored XSS is when any of the nefarious input is stored on the actual hosting site or the hosting the host, or the actual site itself. This can be stored anywhere. It could be stored in a database. It can be stored in a comment field. Right. Let's say a review field. That's one of my favorites, right? Let's leave a review with a payload. And what happens there is that this data is not only, this vulnerability data that's being exploited is not only taking advantage of the user and the session that it's sitting in front of, but it has the impact to reach and be able to take advantage of every user or every session comes into that, that visits that database or that visits that comment field or that message field or something of that nature. And that payload is really permanently stored at that point as part of that database, if you will. And that's replayed as many times as it is until it's removed. Right. And so definitely, in my eyes, a more impactful as a whole, right? We could paint that in a few different brushes. But those are the two main categories that I usually like to use to describe cross-site scripting.
That persistent one is tricky, right? Because that spreads. That might be injected through one vector and then it affects somebody else. And particularly when you're dealing with exfiltration or with other things, as in our short story that happened before, that would be an example of some persistent XSS. Yeah.
It's a perfect example, and it really shows you the impact that XSS can have. And, one thing that we also talk about a lot or get questions a lot, and it's like, look, cross-site scripting occurs. We update our sites and our APIs. Well, not APIs so much in this example, but we update our web applications. We update our functionality almost on some clients will do it hourly, some weekly, some daily, etc. But there's a lot of frequent updates that occur where these kind of vulnerabilities can sneak in. And so we have a lot of people that ask me and clients that say, hey, look, how can we automate XSS detection to be a constant where we know that this is being tested and constantly looked at to make sure that we're not having these vulnerabilities in production environments without us knowing. So Dan, in your opinion, what are one or two ways that you think that could be automated in a way that's not a manual task for someone to be able to find these things and fix them?
Yeah, it's a good question. And the answer is, it's just like 3 simple for loops, right? For each website that you have, for each page on that website, and for each parameter on that website, try some XSS. And, that's very reductionist. It doesn't really work like that way in practice, but, it's a good model for using to understand this stuff. If you wanted to kind of exploit cross-site scripting manually, there's some great things that are out there. There's the Google firing range. There's all sorts of test apps that you can use. And kind of the simplest version is you would go find a parameter that says this is where you put your name. and you're hoping that someone just trusted that blindly. You're hoping that someone decided to take that name parameter from the user and put it into the HTML. So much like our test lab example from before, say your name was something like, image source equals X and on error and a little blob of some JavaScript. What an automated test tool is going to do is it's going to not get tired. It is going to exhaustively find every single parameter. Frankly, doing the sort of work that a manual penetration tester would probably get pretty tired after the 10th value inside of a JSON post of some fetch data. So they're not going to look. But an automated tool will go through each one of these things. And what it tries to do is basically tries different types of payloads, tries to find different parts of this solution that, like the pins of a lock that jiggle and places that you can reflect content into the page. Now, the actual payload that you send, it differs based on where inside of the page you're able to inject traffic. If you're just raw inside of the HTML, the full body of it, you could throw a script tag. But often it's a little bit more subtle. You might have something that has an injection context where it's going into the source of an iframe, right? Where you might have to put just a particular URL to like an offsite machine that has your payload. Or you might be somewhere you have to close one tag and start something new. So there's a lot of these different flavors. So really what we do is introduce yet another loop that says for each recipe in the cookbook of different types of attacks, try to do one of these things. But one of the things that's cool about cross-site scripting is that you can detect it, you can make sure that it's really being exploited. If you consider that most of these automated tools are driving a browser and they're crawling it through every single possible site, every single page in a site, what they're doing at the end of the day is trying to get code to work. And because these browsers are instrumented, we can register a function, almost like a smoke detector, that says, hey, if you manage to call this bit of JavaScript, it's an innocuous function that is a stand-in for doing something really, really nasty. So instead of like stealing all your creds and sending your cookies off to some rando site on the internet, instead, we're going to call a function, and that's proof that you are able to actually execute your own code. So consider something that's registered inside of there that says, look, this will only be called if all of the stars align and you call it for real. You can detect with an instrumented browser that you actually triggered it. So the nice thing is then you can report that with confidence and say, hey, this is something you really have to take a look at because it's not that this could happen, it's that this did happen.
Yeah. And, using benign payloads and being able to substitute that for a malicious payload is not too much difficulty.
Oh, yeah. Yeah. Like in the real world, people will often exploit these things by doing like, script alert one. And what that does is it pops up a dialogue. But, someone can get really excited when they see that dialogue comes up because that's the stand-in for doing anything you want.
I basically can execute my code on your site and have it do whatever I need it to do. There's a lot of creativity that comes in there too, right? So the creativity of, things like on image source or different types of HTML
all the
tags
different recipes, yeah. And
yeah,
we do in Dast, we have tons of these things that we'll go through to try to find out what can get past the filters, try to find out what can make its way and provably be real XSS.
Yeah.
So,
fantastic.
Frank, I think that is all that we have time for today. This is our first episode, hopefully several more to come. But I just want to say, hey, thanks. It's always a blast sitting down and talking shop with you.
You as well, Dan. Always appreciate the conversation.
Yeah, thanks. And thank you all for listening. Have a great day. Our intro music was composed and performed by Zbigniew Banach. Our opening short story was written and voiced by Dan Murphy. Hey, that's me. My co-host Frank Catucci lent his extensive AppSec industry experience to our Q&A section. Special thanks to our marketing team of Megan, Queen, McBee, and Kate Bachman. Goodbye, and thank you for listening to AppSec Serialized.